So in this question, we have been given an array and a sum. So the problem statement is saying that we have to like increase the score, the max to maximize the score. So um, what we have to do here, like we have to traverse the array and we have to take the sum until it reaches even, the sum even, and then we will increase the score, and then we will make it odd by dividing it by 2 continuously, and then subsequently we will do this and try to increase the score. So like so we all know that there are like three cases, like even plus odd is odd, odd plus odd is even plus even is even. So like we have to increase the score, right? And like the sum should be even first to increase the score. So what we can do, we can put the first element, like we can put the first element in the array to be even. Like I'm taking a generalized case, and then like let's say like the first element is even, so we will divide it by 2 and make it odd, so odd is there, so the next element should be odd to make it even, to make the sum again even. So we can put like only one element even, like at the starting, like if there are even elements, and then put all the odds, and then like at last we can keep the even numbers. Like it has no significance, those last even numbers. So there are like this problem is like broadly divided into two, uh, and or that we only have like only odd numbers are there. So I counted number of odds and number of evens. So if there is even, so I will do like 1 plus odd. If there are no evens, so like odd minus 1. So I will explain this part, how this answer I stored. Um, mm, so it is like two cases, right? So even, odd, 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 even, even. So it is like why the answer here is like odd plus one, like because it is like number of odds are here like this, and the one is increased here because the first element is even two, so odd plus one. And if it is like only odd is there, so it, only odd is there, so only odd is there, so the answer is like odd minus 1. Like we will exclude this case, like because the first element, because we want the sum to be even at the starting, but it is odd, so it is like total odd minus 1.
Hello, am I audible? Okay, so let's start with question B. So what is question B? Question B says, uh, Kevin has n stick with length A1, A2 till AN. Kevin wants to select four sticks from these to form an isosceles trapezoid. with a positive area. Note that the rectangle space also connected isosceles trapezoid. Basically, what the question says is you are given a n size array of positive integers, and we have to select four numbers from this array such a way that they can form an isosceles trapezoid. So, what is an isosceles trapezoid? You can click in this link. There is a Wikipedia document given here. So you can read what is the isosceles trapezoid. Basically, trapezoid is a geometrical figure in which the two sides are parallel and the two legs having equal length. Basically, two legs having equal length and two sides are parallel. So what we get here is the two legs must be of same size. So in order to select four numbers which can form the isosceles trapezoid, there must be at least one element whose frequency is 2 because we want these both legs to be equal. So at least there should be one element in this array whose frequency must be 2. If it is so, then we will select that two element for our leg, for the leg of the isosceles trapezoid. What about the other two? This is where the question becomes tricky. Finding these two length. So let me discuss few cases. If we get at least two elements, if we get two elements, let's say if we get two elements, if we get two, if we get two elements, means having frequency greater than two. Let's say 5, 5, 10, 10. Then 1, 5, 5, two element whose frequency is greater than 2, then we simply print that two elements. Because why so? Because these two equal elements can form the leg and these and other two equal elements can form the parallel sides. So what is the basic thing here? If this is the first case, this is the first case, first case. Second case is at least one element having frequency greater than equal to 4. Let's say there is one element, let's say 2, which have frequency greater than 2, which have frequency greater than 4, sorry. Then we will simply select 2 4 times, then it will form a isosceles trapezoid because there it is clearly mentioned that isosceles trapezoid can be a square or rectangle. So in the first case, this is a rectangle. Both the sides length is equal and breadth is equal. So this is a rectangle. In the second case, when there is at least one element having frequency greater than equal to 4, this is a square. So these two cases are clear. What if both fails? What if we are not able to find what if we are not able to find the first case and second case? Then here also comes two case. Case one, if there is no element having frequency greater than equal to 2, means there is no element having frequency greater than equal to 2, means we are unable to find this leg. This leg must be of the equal length, and if we do not have any element having frequency greater than or equal to 2, simply we will print -1 because there is no choice for legs because the legs can be of equal length only. So if there is no element having frequency greater than or equal to 2, then we will simply print -1 because there is no option for legs. What is case 2? Case 2 means now here only one element is there having frequency 2. Now if there is two element having frequency greater than equal to 2, we'll just simply print that two number. If there is one element having frequency greater than equal to 4, we will simply print that number because this is a square, this is a rectangle. If there is no element having frequency greater than equal to 2, means we are unable to select leg. And in this case, we will print minus 1. Minus 1, why? Because we are not able to construct any isosceles trapezoid. So what is the remaining case? Remaining case is that there is one element having frequency 2, but there is no other element having repeating frequency. So in this case, we need to find two side A, two sides, let's say B and C, such that isosceles trapezoid exists. We need to find two sides B and C such that isosceles trapezoid exists. So now the question boils down to selecting A equal to equal frequency element, and we have to find these two elements B and C such that the valid isosceles trapezoid exists. Now, how is this B and C we can find? So let's go to the document only. So in the document, we are given the height formula. Height is equals to 1 by 4 under root 4 c square minus a minus b whole square. What is this c? C is the equal length frequency. Means this a have C is the element having frequency at least 2. So this we have already found. This we will already find in the code that what is that element whose frequency is 2. So this C we know. Now I will set this 1 by 2 inside the root. So what will it become? 4c square by 4. So 4 get cancelled, c square minus a minus b by 2 whole square. So in order to in order that this to exist a isosceles trapezoid, this A and B should in such a way that this height is greater than 0. If this height is 0, we are unable to find the isosceles trapezoid because here it is written the positive area. Positive area means greater than 0. So in order to ensure the area is positive, this height should be greater than 0. So in order to ensure this height is greater than 0, only one case is there, that this C should be greater than A minus B. So last and most important case is this A, this 2 times A should be greater than absolute of B minus C. Why 2 times? Because this is written by C square by 2. So if we are able to find if we are able to find two numbers B and C such that their absolute difference is greater than their absolute difference is sorry less than 2 into A is equal frequency, then we will select that two elements B and C, and our answer will be A, B, and C. If we are unable to find those B and C, then our answer will be minus 1. So this is the total case that we get in question number B. I hope I am clear with this. Am I clear? Okay. So let's move on to the code of this question. So let's move on to the code. So I have taken n integer vector I have taken n as input and I have sorted it. I have created a map. Initially a and b are minus 1. I have stored it in map. Then I have found this case. If any element having frequency greater than 4, if any element having frequency greater than 4, I will print that element. It is a square. If any element having, if there exist two element, I am storing that two element whose frequency is greater than equal to 2. And here I am checking this case. If there is at least two elements whose frequency is greater than or equal to 2, then I am simply printing that two numbers. This is the rectangle case. Okay, I am clear with this. If A is minus 1, means there is no element whose frequency is greater than equal to 2. This is this case. So in this, I am simply printing minus 1. Now, for this, I am using a multiset. In multiset, I have stored all the elements of B and I have erased these equal elements. I have erased these equal elements. Now remaining element, and now in the remaining element, I will try to find this B and C such that this absolute of B and C is greater than 2 into A. Let's say I have found out C, then I have checked absolute of D minus C. Here I have used D minus C, here I have written B and C. This is one and the same thing. So if absolute of D minus C is less than 2 into A, then we will simply print A, D, and C, and I will return. If we are not able to find any such B and C, then we will exit and print minus 1. So this is the code, and this is the whole question. So it's a good question. Am I clear? Okay, so this is for the question number B.
Hello, I'm audible. So I will be discussing the second question of today's contest. So this was the second question. So the question states that we have given a logic puzzle where there are 10 classmates and the ith person says their AI lies before it. Means if the index is what I can say, like if the index of like in this one. Means here three persons are there at index 0, 1 and 2. So here index 0 is saying there are 0 persons before me that are saying lies. Here one is saying at index 1 is saying there are 1 person before me that is saying lies, and here 2 is saying that here are 2 persons before me that are saying lies. Means a person can be either, here it is written, a person can be either a liar or a either a liar or a honest person, but there is one restriction that two liars cannot be next to each other. This is one constraint we have given in the question. The liar can say truth or lies. Means the liar means we cannot detect a liar by saying if he is saying a truth, we cannot surely say that he is a liar or not. But if he is saying a lie, we can say obviously say he is a liar. But if he is saying the truth, it can be honest or a liar. So and here we have told to find the maximum determine the number of distinct possible combinations, all the possible combinations that can be from this any random person is a liar and any random person is a means if an J exists where the J is a liar and in another J that is a he's what I want to say. He's a liar or he is a honest person. Is in some J he can be a liar. In some J if he is sorry for the interruption. Let me continue explaining the question. So as I told that we have to find the number of distinct possible games. Means what I mean distinct means in some index, he will be a liar or he will be a joker, honest person. Means both means at some index, if both are different, so means both games will both combination will be counted as distinct. So we are given we have to the number can be very large, so we have to modulo this number. So the number will be in range, means 20 or 9 range. So we have to output that number. So so from this line, you can think of a DP problem, number of distinct possible games. This this line most of the times, this lines means how many we have to count all the type of combination. So means mostly refers to a DP problem. Then I will show you the example, means the combination 0, 1, 2. So in a DP problem, what we do is that we calculate this much steps, then we try to calculate for this. Like if there is 0, so we will previously calculate what are the previous all elements. Then we will calculate for this, including this plus this. Then if there is again one more element is inserted, 1. So we have already calculated this. So we will insert this and we will try to calculate all the combination which occurs from this plus this. Then again, if 2 is inserted, then we will try to, we have already calculated from here to here, then we will try to calculate this plus this, and the final answer will come. So, so I'm showing how we can calculate this. Is 1 is the 2 is the. So first can be true or false. I believe this is okay. First one can be true or false. Okay. Then another one will come. This can be true or either false. So if it is true, 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 this statement is correct. If it is false, then this can be false. This can be false, true, false. This is also a combination. This is false, this will be true. This is a combination. False and false cannot come together because it was given earlier in the question that it is not possible. True, true. See, this cannot be a combination. See, true and true cannot be a combination. Why? Because see, if he is saying true means there are no liars before it. Okay, so this is false. Means this is true, and he is saying that there are one liar before me. Means from year to year there are one liars. So here is only one person, but we have already said that he is saying the truth. So this is not possible. This case is not possible. This case is possible, and this case is also possible. What was the other case? True and false, and this was false and true. This this case, this case is also possible. Then was 0, 1, 2. So what we saw, which case was possible, true, false, and false and true. Then we will check now which case of possible from here. So here can be true or false. Okay. So here can be true and false. We will check. See here if it is true. So means there are two liars between before us. But here I said he's saying true, he's saying false. There is only one lie. So this cannot be a case. Okay. So this is one more case is false. Okay. So if this is false, if this is false, so means there are only two liars in the means he's saying the truth. That can be a case. Okay. So and then here true or false. There can be two cases. If he is saying true, so means there are two liars in. But here we found out that only one liar. So this cannot be a case. Then this is one case that so this is one more case that false, true, false. Okay. So here 0 is false, means there are no liars between before him. Here is saying true, so here one liar between him. He is saying the truth. Here is saying false, means there are no two liars between him. This is one correct case. Okay. So what is the answer? This is one. So this case is not correct. This case is not correct. Which one case? True, false, false. 0, 1, 2. True, false, and false. This case is not correct because he's saying the truth. He's saying that false is to correct, and he's saying correct. Why this is not correct? Uh, this case is not correct because 0, 1, 2. True, false, false. Here, yes, this is the only correct case. 0 for 0, 1, and 2. False, true, false. Uh, then so here you can see the you have to check for all the combination and so on like that. So I am saying this DP here need to mention the state means how they are changing from one state to the another. So see The first base case, we need to write the base case. Okay, let's write the base case. So you saw 0 has no means there is no previous element from 0, so there is no problem for it. So if he's saying the truth, means I see what I try to do. Let's keep a pair where we keep the keep the count of all games possible and the number of liars before. So I'm keeping the track how many liars are before it and the number of count of games in a pair. Okay. So what I will do that I'm taking a step that I and means means 0 or comma 1 where 0 is defining a honest person, nice, a liar, and 1 is defining a honest person. Okay, this is two cases. So what I mean by this dp of I comma 0 or 1, so this means that it is keeping mm, dp of I comma 0 comma 1 is keeping a count of, of number of games possible and number of liars before it. Okay, so we can say dp of 0. The first person can be a liar, so it can be 1 comma 1 because he is a liar. He is a liar, and 1 is because this is one only one. If here is only one, so one combination is only possible. One combination is possible. dp of 0 comma 1. So the what is the case that the 0th person is true? What is the case? So he must say that his value is 0, means v of I should be 0. If v of I is 0, means he is truthful. If it is not 0, means he is just telling a lie for sure. So here I wrote, so here I am taking, so I'm check, so I'm checking that if v of I equals to 0, then I'm saying that this person is a truthful. So I'm saying 0 means there will be only one game possible and he's truthful, or else dp of 0 comma 1 is 1 0 comma 1 because who is a liar? We know he's a liar. So I'm keeping a count of the liar. It does not affect that. Uh, it does not affect that he is not. He's what is the state means it is truthful or not. He's a liar to liar, and 0 means he's a. You can see 0 whenever it will be a 0. Answer is 0 is the answer when he is a liar. When he is always the liar means there is no other case that he is not a liar. Means he cannot be an honest person. He will be a liar. So this was the base case. These two are the base. This from here to here is the base case. Then we have to deal the state change. Okay. So you know dp of I of 0 means he is a liar. He is a liar. So he is a liar means what? The previous person cannot be a liar because we have said that lie cannot come together. These two person cannot come together. So he must be a non-liar. So I'm just doing dp of I minus 1 and I minus 1 1 means this person is not a liar, is a honest person, and dot ff means the first element means as I am storing in a as I'm storing in a as I'm storing in a honest as I'm storing in a pair, so I'm using dot first operator. Then I'm just keeping the counter of the liar is dp of I minus 1 dot fs. Yes, last, okay, and plus 1 because the currently the person is the liar, plus 1 because current person is a liar. Okay, this is for he if he is a liar. If he is truthful, if he is truthful, so means dp of I comma 1. He is truthful. So what do you mean by truthful? Means means what do you mean by truthful? A simple example is that if he is saying v of I before our liars means b of I are liars means this only. So I have to check that before I if b of I are liars, so I'm checking that if dp of I minus 1 0 1 equals to v of I means he is saying the truth. So I will add these numbers dp of I minus 1 0 1. So last person can be a liar, but he can say the truth also. Like dp of I minus 1 I minus 1 of 0 dot ss means second this is the second because the second is count keeping the count of the layers is equals to v of I means this last person which is who is saying lie he can be truthful means he can say the correct number of that also. So if that is also same, then we are just going to sum of that dp of I minus 1 0 because the last person can be a liar can be not a liar, both cases we will count. Then what we will do if this sum equals to 0 means we can surely say that he is a liar. We can directly say that. If he is a liar, then what we will directly do? He will do dp of I minus means dp of I of 1 is a liar, so he will be having some 0 and his liar counter will go by 1. dp of I means I minus 1 1 dot ss plus 1. Okay. Else else so I am writing dp of I 1 is equals to the sum and the counter will not increase and but he's saying the right, so he will just have this one. Okay, so this was how the state changes. This this one was the state change, how means the state was changing. And lastly, then we have just need to do this mod and all, and we have to just print the sum of dp of n minus 1 plus n minus 1 if he's a liar, and dp of n minus 2 minus 1 if he's a truthful person. So I'm going to the implementation. So here is the implementation that here I have taken the input of the vector. Then I have initialized a dp vector, 2D vector, dp of I comma z, where I comma 0 comma 1, and where this is 2 is this is where this is giving the count of the games, count of games, comma this is the layers, number of layers. Okay. Then here I'm just taking these two base cases. These are the two base cases I'm covering. This if is a liar, so this is nothing but 1 comma 1, because there will be one game possible, and this is the number of layers, so he is a liar to 1. And if he's not a liar, so 1 comma 0, and if he is a liar, so 0 comma 1. Okay. So this is in I equals to 1, I less than 1, because first only I have initialized type. Then I am taking the count if he is a liar. So this is if he is a liar. If he is a liar. And this full is if he is not a liar. If he is a honest person. So what I am doing, that I am taking the this count with how many games are possible and how many liars are there. So I am just doing simple, because the last person will be a true person. So I am not checking much yet. So I am just putting count and liar plus one. Okay. Then I'm taking a sum variable where I'm checking if he's truthful. If he's truthful, then I'm checking the last element is singleized truth or not. So I'm checking it some. If he's saying with both cases, I'm checking this. If he last person is truthful or the this liar, this one is the liar one, this one is the truthful one. Then I'm taking the summation of both of them. Then I'm just doing mod of that, because we have to keep it in the range. Then I'm checking if there is a sum possible, means both are v of I is anything one, then is not if is what I'm saying, sum is zero. This condition can be said sum is zero. Then I will doing sum, comma if he is a liar, so he plus one, and if he is not a liar, is if he is not a liar, then sum, comma is v of I, is if he is saying the truth. Then lastly, I am taking the sum of these two elements. D proof and if he is a liar or truthful, then I'm just printing out the answer. This was the implementation of this program.
Am I audible? Wait. Oh yeah. So so if the screen is visible, then I can continue now. Yeah. So in the D problem, we are given two sequences like A and B, and we have to make the multiset of A and B equal. Like we have to make both of them equal. Like the elements must be equal, and we have to perform some operations on array A. So we have to pick some two values such that their absolute value is less than or equals to 1, and then we have to remove both the elements from the array A and then insert it back x plus y, the sum of the numbers. So we have to make the sequence A and B equal, like the elements must be equal. Like here it's mentioned, we have to make the multisets identical. So let's understand what the operation is exactly doing. Like we are making the absolute sum of x and y when it's less than or equals to 1. We are kind of erasing x comma y and pushing adding, we are adding x plus y, right? So what does this exactly mean? Like let's understand the operation. Absolute value is less than equals to 1 means either x is equals to y, this is one case, either x is y minus 1, other x is y plus 1. If these three cases are clear, then I'll move on. Like if these are clear, then I'll move on. Three cases. Yeah, so these three cases are clear. Then the problem is simple now. So what now I'm going to raise a few points. Like some value is if present in both of them, some value is present in both of them, both A and B arrays, then we can simply ignore that element, right? It does not really matter because it's present in both of them. Yeah. So if this is clear, then let's see. So when suppose let's take some element y, somewhat like a capital A element is in B, but not in A. So it's in B array, but it's not in A array. So if the element A is kind of even, if this is even, then we will check whether we have a by 2, capital A by 2 and capital A by 2 in array A, because that's it. So because when the number is even, we can simply split it into two parts, and we'll check whether two of them are present in the array A, because then we can merge them into one and we can thereby make it equal to the element in the B array. Like, is this clear? Like when the n is even, like this is the only way to make it, or else there is no other way. Like, I want to know. Yeah, like, is this clear? Like, this is the only way, a by 2 plus a by 2, or else there is, you can check. So I can also give some example if you guys need. Like, it's going to be a by 2. Yeah, suppose the value 4 can be written as 2 plus 2. Like, this is the only way we can write such that the absolute value is less than equals to 1. This is the only way, one and only way. Okay, so now let's take, there is some odd number in array B which is not in A. Let's take some odd number, right? Suppose 5 is there in array B which is not in array A. So this is the only way to write 5 by 5. This is the only way, right? Because there, otherwise the absolute value will exceed 1, right? This is the only one and only way to produce it, that we have to sum 2 and 3 to get 5. There is no other way. So here in that case, we have to do like this. Let, if the number is odd, if the number is odd, then we have to do somewhat like this: a by 2, and this will be the first number, and the other number will be a minus of a by 2. Like, is this clear? Like, we have, this is the only way to make it. The absolute difference must be less than or equals to 1, right? Then only we can merge them and make that element. So this is the only way if the number is odd. Like, I want to know. Yeah. So is this clear? When the number is odd, this is the only way. There is no other way. Like, yeah. So, like, you can understand some examples. Like, if you guys want, I can give another example. Like, if we want to produce some 8, suppose let's take 15. You want to produce some 15. The only way to produce 15 is somewhat like a 7 plus 8. There is no other way, because otherwise the absolute value is will reduce, will be greater than 1, which is not possible. So obviously when the element is already present in both the areas, that does not really matter. So this suggests us that we are halving the elements, right? Halving the elements elements. So this suggests us we can use some recursive procedure, recursion, to solve this in logarithmic time, because like we are halving each and every element, right? It is like it's going to take log 2 at max, log n at max. Like, is this clear? We can use recursive procedure now. We'll just solve it recursively. And yeah, so is this, if this part is clear, then we can directly move on to code, because there is nothing more to say about this problem. We'll just check whether we can produce each and every element in this recursive manner. Like, we'll maintain a hash map. We'll maintain a hash map basically for the array A, and then we'll traverse the array B and we'll check for each and every element of B whether we can produce it. That's it. And we are simply going to use recursive procedure. So what is the recursive steps? I will explain directly in the code because there is nothing more to do here. Yeah, let's get into the code then. If the recursive procedure, yeah. So basically here, this have map, as you guys can see, this is just the hash map, and I've just cleared it. I've taken the input initially of the array A and B. Yeah, what's the, yeah. So I've taken the input of array A and B. Yeah, and I've incremented in the hash map, whatever. Yeah, now I am traversing the array B and I'm trying to check whether I can produce each and every element of B, array B. Yeah, now the problem, the main thing is in the recursive function. So this is just, I've just given the name db, there is nothing deep here. It's just a boolean variable, right? We want to check whether you can get the sum, that value, through some operations, right? Okay, so if that element is negative, we can clearly say that less than equals to 0. We can clearly say that we cannot produce a negative number because the array A will never contain a negative number, right? Okay. So already if the number is present in the hash map, then it does not make any sense. We are just going to decrement that element. This is really important step. We have to decrement it because otherwise there is a possibility that that element is present multiple times. So we have to decrement it and then return true. Okay, so we have written true. This is simple. If that element is not present, then we have to check whether we can produce the x by 2 element, x by 2 element, and this is the x minus x by 2 element. We both of them must be present simultaneously, then only we can produce the sum of the numbers, right? Both of them must be present simultaneously. Is this clear? Like, I'm ready to yeah, I want to know whether this is clear. Yeah, is this clear? Like, we both of the element must be we must have the capability to produce both the elements simultaneously so that we can sum up to get x. Yeah, so I'm reducing this is really important step because or else we may use it multiple times and it would give us the wrong answer. So I'm using bitwise and here, like both of them must be true, then only we can produce the sum. Yeah, so this is just an if to check whether we can produce. If we are not able to produce the sum, then we'll simply print no. That's it. And then we'll traverse the hash map have, like this is just the hash map. And if there are some extra elements left out in the array A, then it will then also it will be no answer, right? There must not be any extra element in array A. This is really important because I personally have done wrong here initially, but then I realized there should not be any extra element left out in array A. They must be completely same. That's what is mentioned in the question. So I'm just checking out whether there is any extra element. So if there is extra element, then we cannot make them equal. And at the end, I'm printing yes. That's it. So I want to, yeah, any doubt or whatever. Yeah, if the process is, if the solution is clear, then let's end the